Basics of statistics. This video is about variable measures. Topics of this video are: first, an introduction, measures of sample, measures of population, round-off errors, and calculation principles. First topic, introduction. A statistical variable is a variable that takes different values non-deterministically. That non-deterministic part is important. Deterministic variable is a variable whose value is known or can be calculated. For example, x equal to 3 is a deterministic value that is calculated. Non-deterministic variable, a variable whose value is not known or cannot be calculated. It can only be observed. For example, y is equal to 3, 2, all the way to the last one. Every value is observed here. Population. It is the subject of the statistical data. It is what the statistical data represents. Sample is a portion of population, a portion of all possible values of variable in a population. Here, there's a picture, the whole population is given, and sample is a small portion of that population. Here I have home sales data, two variables, price and size, and population is the price and size of all homes. Sample is price and size of 72 homes in the data you see here. Measures help to understand values of a statistical. There are some measures to find out the center and the spread of data. For the center, one measure is called mean, and it finds the average. Its notation is x bar. Another one finds the middle. It is called median, x hat. Another one wants to find the most frequent value of data. It is called mode and shown by x tilde. Measures for a spread of data, they all show how dispersed data is. One is called variance, S square or sigma square. A standard deviation, S and sigma, and quartiles, Q1, Q2, and Q3. Measures of sample, particularly number of observations, and mean. Here, house price data, we call it X. 5 houses prices are written here, and in this figure, we saw all the values of this variable. Measure 1, number of observation. The calculation counts how many observations are in the data. In other words, it counts the number of rows in the data. Notation, a small letter n represent the number of observations. For the variable x above, there are 5 observations. That means n is equal to 5. Measure 2, mean of variable. Calculation. It is the average of variable. In another word, x bar is summation of x divided by number of observation. Notation, the mean of a variable is shown with x bar. The bar over the variable shows that. Example, consider the variable x in the left that shows the price. Calculate the mean of variable. Here's the answer. There are 5 observations, which means n is equal to 5. To calculate the mean, x bar is summation of x divided by n. What are the x's? 1900 and 500, 95 and 100. Sum them up together, divide by 5, which is 495 divided by 5, which is 99. Another example. Consider the following table that observes dealership and how many cars in different models they sold last year. Calculate the mean of each variable. Here's the data. Pause the video and calculate. Here's the answer. There are 8 observations, which means n is equal to 8. In addition, there are 4 variables, which are Tesla X, Ford Y, and Honda Z. X bar is the summation of Toyota, which is 30 plus 40 all the way to 46, which is 319 divided by n, which is 8, which turns to be 39.875. For the Ford Y bar, the same thing. We have the same results. And let's skip to the Honda W. Summation of its values are 20, 35, all the way to 40. We sum them together divided by 8, which is 284 divided by 8, which is 35.5. Measures of sample, this time median and mode. Measure 3, median of variable. The calculation, it is the middle value among all those values. Assume x is a statistical variable, order its value from the smallest to the largest. The value that stands in the middle is the median. If two values are in the middle, then assign their average as median. The notation for x, for the median of x, is x hat. Here's an example. X is 90, 105, 100, 95, and 100. If we order the observations, there will be 90, 95, 100, 100 again, and 105. The middle point, the middle value is 100. That means x hat is 100. Here's another example. X has values 70, 45, 30, 25, 35, and 42. If we order the observations, the values, ordered values will be 25, 30, 35, 42, 45, and 70. The middle point, we have actually two middle points, two before and two after that. So the average of 35 and 42 will be the median, which is 38.4. Measure 4, mode of variable. Calculation, it is the value of a variable that has the most frequency. If two values have the most frequency, obviously the two frequencies should be equal. Then the variable is bimodal, having two modes. If more than two values have the most frequency, or if the frequency of all values are equal, there is no mode for the variable. Here's the notation for the mode. We use x tilde. So there's a tilde sign over x. And here's the example. Consider the data in the following table. It shows the number of customers in coffee shops on Mondays and Tuesdays. Calculate the mode for each day. Here's the data that you can see here. The answer, let x be the Monday variable. Value 30 has the most frequency, repeating 3 times. Then the mode is 30. X tilde is equal to 30. Let y be the Tuesday variable. Values 40 and 42 have the most frequency, which is 2. Each is repeating 2 times. Then the mode is both 40 and 42. So y hat is equal to 40 and 42. Mean is sensitive to large values of variable. Median modes are not sensitive to the large values of variable. Here the example, x is 90, 100, 105, 100, 95, and 100. As you can see in this figure, x bar is 92, x hat and x tilde are 100. If I change 105 and 205, then x hat and x tilde will remain the same, but x bar will increase to 118. So mean is sensitive to large values, but median and modes are not. Measures of sample, variance and standard deviation. Measure 5, variance. Variance is the average of square distances from the mean, sort of. S squared, the formula, S squared shows variance. It is equal to summation xi minus x bar squared divided by n minus 1. xi minus x bar is the distance. When I square it, it's the square distance. When I sum them, it's and divide by n minus 1 is sort of mean. Standard deviation is the square root of the variance. So S is the square root of S square. Here's the example we saw in previous minutes of the video. X has values 19, 105, 100, 95, and 100. X bar is 99. The distances from each value to X bar, as you can see, from 90 to 99, distance is minus 9. From 95 to 99, it is minus 4. And if I follow the formula, I have to find all these distances, square them, sum them together, divided by n minus 1. 5 observation, n is 5. So all these values, the distances are squared and summed together. It will be 135 divided by 4, which is 33.75. So variance, or S square, is 33.75. We can also make a table for the calculation. Here, 90 minus 99 is minus 9. 105 minus 99 is 6. 100 minus 99 is 1. 95 minus 99 is minus 4. 100 minus 99 is equal to 1. Now let's square these values. Minus 9 square 81. 6 square is 36. 1 square is 1. Minus 4 square is 16. And 1 square is equal to 1. And S square will be summation of these squares that I calculated in the third column. 81 plus 36 plus 1 plus 16 plus 1 divided by n minus 1. N, number of observation, 5. N minus 1 is 4. Those summation 135 divided by 4, which is 33.75. So S square is 33.75. I prefer the second calculation. To calculate standard deviation, we need to calculate variance first. Here's the example for that. Consider the following data. Calculate standard deviation of variable Monday. Also calculate standard deviation of variable Tuesday. Here's the data. This is the coffee shop data we used before. Answer. To calculate the variance, first let's x be the variable Monday. There are n equal to 5 observation, and the mean for Monday is 33. And here I go with the table. I have Monday 30, 36, 30, 39, and 30. I subtract the mean from every of these values in the second column. 30 minus 30 minus 33 is minus 3. 36 minus 33 minus 3, 6 minus 3. If I square them, I get minus 3 square 9. 3 square 2 minus 3 square 9, 6 square 36 minus 3 square is equal to 9. And this way I will have all the square. Then I sum them all together. 9 plus 9 plus 9 plus 36 plus 9 divided by 5 minus 1. 72 divided by 4. So S square is 18. And standard deviation is the square root of 18, which is 4.243. Part B, to calculate the variance of the variable Tuesday, let's y with that variable. There are, again, 5 observations, and the mean is 41. And the table will be constructed the same way. The 41, the mean will be subtracted from each value in the second column. So 40 minus 41 minus 1 all the way to 42 minus 41, which is equal to 1. In the last column, I square these values of the second column. So minus 1 square is 1, 1 square is 1, 0 square is 0, minus 1 square is 1, and 1 square is 1 again. Now, as you can guess, I calculate the variance first. S square is the summation of the last column, 1 plus 1 plus 0 plus 1 plus 1 divided by 5 minus 1, which is 4 divided by 4. So variance is 1. The square root of variance gives a standard deviation, which is the square root of 1 equal to 1. Measures of samples quartiles. This is measure 7. Q1 is the first quartile. 25% of observations of a variable are below this number. Q2 is the second quartile. 50% of observations of a variable are below this number. It is also median. Q3 is the third quartile. 75% of observations of a variable are below this number. The steps to calculate that: first, sort observation of the variable, same as sorting as to find median. 2, find the position of quartiles. Index K. For QP, P equal to 1 for Q1, P is equal to 2 for Q2, and P equal to 3 for Q3. K is P times 0.25 times N. If K is integer, QP is the average of kth and K plus 1th sorted observations. If K is fractional, QP is the integer part of K plus 1. Here's the sample Y. I sorted the values, and 25% of observations are less than Q1, 50% below Q2, and 75% of observations less than Q3. Here's the example. Find quartiles of this variable, x equal to 3, 2, 1, 6, all the way to 1. First step, sorting variable x. There are 20 observations. So these are the sorted values: 1, 1, 1, 1, 2, 3, all the way to 9. Step 2, finding k and quartiles. For Q1, k is equal to 1 times 0.25 times 20, which is 5, integer, which means Q1 is the average of 5th and 6th sorted observations, which means Q1 is the average of 1 and 2, it is 1.5. For Q2, k is equal to 2 times 0.25 times 20, which is 10, integer, average of 10th and 11th sorted observations. Q2 is the average of 4 and 6, which is 5. For Q3, k is equal to 3 times 0.25 times 20, which is 15, integer again. Q3 is the average of 15th and 16th observations. So it is average of 8 and 8, which is 8. Example 2. Find quartiles of this variable. Y is equal to 6, 1, 4, all the way to 1. Step 1, sorting variable y. There are 18 observations, n equal to 18. So these are the sorted value. First ones appears, then 2, several 3, all the way to 9. For Q1, k is equal to 1 times 20.25 times 18, which is 4.5 fractional. Q1 is the integer part of 4.5 plus 1, which is 5. So Q1 is 5th sorted observation. For Q2, it is 2 times 0.25 times 80, which is 9, integer. Q2 is average of 9th and 10th sorted observations, which is the average of 4 and 4, which is 4. Q3 is equal to 3 times 0.25 times 18, which is 13.5 fractional. So Q3 is the integer part of 13.5 plus 1, which is 14. 14th sorted observation shows Q3, which is 7. Measures of population. Up to this point, we learned about measures of samples, which was the mean, median, mode, variance, standard deviation, and quartiles. Now, what about population? Can we use the same thing for the populations? And the idea is that we mostly can, but with a different notation and a slight difference in variances. Measures for a population are mostly identical to measures of sample, except for variance. For the population notation, the Greek letters are used. N is now capital N, X bar is mu, S square is sigma square, Greek letter, S is sigma. S square and sigma square, the formula is different, in which the S square, the result, that summation is divided by n minus 1, while in sigma square, it is divided by n. So in population variance, we have the absolute average of square distances from the mean. Instead of using n minus 1, we use capital N. So here in the table, different measures for sample and populations are compared. Number of observations, both are based on counting, but the notation is different. For the mean, notations are different, but the formula is the same. So for the sample X bar, for the population mu, variance is a square in the sample, but for the population sigma square, and the formula is slightly different because it is being divided by n. And for the standard deviations, pretty much everything is similar. Next topic, Randolph error. While doing calculations, one may encounter many digits after the decimal. For example, the result of 1 over 3 is 0.33, and it continues. To represent this number, one has to use a few digits. For example, you may use 0.33 instead of 1 over 3. Using 0.33 instead of 1 over 3 creates an error of 0.0033, and it continues. Adding up all these imprecisions can become very problematic. Here's an example. Let's calculate 2 over 3 plus 10 over 7 plus 23 over 4 using 2-digit precision. Here's the answer. 2 over 3 plus 10 over 7 plus 23 over 4 is 0.66 plus 1.42 plus 5.75, which is 7.83. Actual value using calculator is 7.8452. The error is 0.052. This error may not be that much, but it can be accumulated and it will get worse over time. To prevent issues related to that as much as possible, use 4 digits of precision when doing calculation by hand. Next, calculation principles. Order of calculation is as follows. First, we do the parentheses, then functions such as exponents, square roots, etc., division and multiplication, left to right, addition and subtraction, left to right. Note, while writing an expression to evaluate, utilize steps 1 to 4 to get the correct result. Here's an example. Evaluate following expressions. A, 6 times 4 divided by 8. B, 7 plus 23 times 5 divided by 10 times 2. Here's the answer. For part A, it is 6 times 4 divided by 8, 24 divided by 8, which is 3. For part B, first we do the parentheses, 23 times 5. So it is 115. Then we are going to do subtraction because it is on the left. The result is 1.5. Then we will do the multiplication. 11.5 times 2 is 23, and then summation. 7 plus 23 is 30.